So, good morning everyone. First of all, I will introduce myself. So, I'm Jomari G. Binalino from BSAMT 2A. Today, I will discuss about induction system reciprocating engine. So, uh, induction system reciprocating engine, the basic induction system of an aircraft reciprocating engine consists of an air scoop and ducting. So air scoop used to collect the inlet air, and the ducting is the transfer the air to the inlet filter. So the air filter is generally housed in the carburetor, heat box, or other housings close. So that is attached to the carburetor or fuel injection controller. So the air scoop is located on the engine cowling to allow maximum airflow into the engine induction system. So the air filter prevents dirt and other foreign matters from entering the engine. It filters air, enters the fuel metering device, where the throttle plate controls the amount of air flowing to the engine. So the air coming out of the throttle is referred to as manifold pressure. This pressure is measured in inches of mercury and controls the engine power output. So we are going to non-supercharged induction system using a carburetor. So this is a figure is a non-supercharged induction system using a carburetor. So we have air filter, carburetor air valve, and carburetor and temperature valve, drain line, carburetor air actuator lever, and air intake duct. So air filter, it filterizes the air coming inside the air intake duct, and the carburetor air valve, it selects an alternate warm air source to prevent carburetor icing. So the carburetor, a device for mixing air and fuel. So the temperature valve, it senses the temperature, whether it's cold or warm. So the drain line where the moisture carried by the air goes down, and the air intake duct is where the air coming inside. So we have this color, blue. It's what we call ambient air. Ambient air came from atmospheric air. So we have warm air and cold air. So the next is induction system. Induction system is consists of several different arrangements. Two that are used are the updraft and downdraft induction system. So an updraft induction system consists of two runners and balance tube with intake pipes for each cylinder to deliver induction air to each cylinder intake port. So the major parts of the updraft induction system, we have balance crossover tube, hose clamp, hose, induction risers, induction elbows, and throttle body. So, hose. What is hose? Hose is connects the induction risers, and the throttle body controls the amount of air entering the engine. And we have balance crossover tube. It is used to reduce the pressure imbalance between the two-side induction runners. And also we have hose clamp. Hose clamp is a device used to attach and seal a hose onto fitting such as a valve or nipple. So, let's proceed to the downdraft induction system. A downdraft balance induction system provides optimum airflows to each of the individual cylinders throughout a wide operational range. Better match fuel to air ratio. Provide a much smoother and more efficient engine operation. Air. So we have downdraft balance induction system. So this is the figure of downdraft balance induction system. So we have throttle body, hose, intake manifold, induction manifold assembly, intake manifold tube, and intake gasket. So, what is a throttle body? The throttle body is used to control the amount of air entering the engine. And also we have hose. Hose connects the intake manifold tube. And intake manifold tube it is the passageway of the air directly to the engine. And also we have intake manifold assembly. Intake manifold assembly, it separates the distribution of the air. It separates the distribution of the air through each intake manifold. And also we have intake gasket. Intake gasket, it secures and seals the air tube to intake manifold through the engine. So, let's proceed to the induction system troubleshooting. So, induction system troubleshooting, when the aircraft engine fails to start, so we have probably cause. So, we have induction system obstructed and air leaks. So, the isolation procedure is inspect air scoop and air ducts, and also they have a inspect carburetor mounting and intake pipes. So the correction: removes obstruction, tighten carburetor, and repair or replace intake pipe. So the engine runs up. We have loose air ducts linking intake pipes, engine valve sticking, vent or womb valve push rod. So the isolation procedure of the loose air ducts is inspect air ducts, inspect intake pipe packing nuts, removes rocker arm cover and check valve action, inspect push rods, and then the correction of the engine's runs wrap. We have tighten air ducts, tighten nuts, lubricate and pre-sticking valves, replace worn and damaged push rods, and also lower power. Lower power, restricted intake duct, broken door in carburetor, air valve, dirty air filter, and the isolation: examine intake duct, inspect air valve, inspect air filter, And the correction is remove restriction, replace air valve, and clear air filter. So that's all of my topic, and thank you.